All right. So this first part is a little bit review. It says consider this graph. Let's go ahead and write these points down. That just seems a good place to start. F, G, H, J. I got this thing about alphabetical order. I don't know. It helps my brain think clearly. Okay, what are the coordinates for F? -4, 3. Okay, G is -1, 3. H is -5, 1. Okay. J is 0, 1. Marvelous. Okay. Now it says quadrilateral F, G, J, H. Is anyone annoyed that that is not in alphabetical order? You can't even switch it. Yes, sir. Yes. Do you know why they left out I? It looks like a 1. It's the same reason they often don't use the letter O. Yeah, it doesn't look like a number if you do the lines across the top and the bottom, so you could do that. I think the font that they had, though, this font, see the I there? That's probably why they left out the I, because of this font in particular. It's also why they typically leave out the letter O, because it looks like a 0. It's also why if you see a lot of math teachers, when they write a Z, they don't write a Z like that. Most math teachers will not. Most math teachers cross their Z's, so they don't look like 2s when you write fast. Yeah, and a lot of math teachers will do T's like that, so they don't look like plus signs. Yep. So it doesn't look like a 1. Yep. Yeah, you'll notice a lot of people who do math consistently start so that their letters and their numbers look different. Yeah. So the other thing is when you write the numbers, or sorry, not the numbers, when you write the letters for something like this quadrilateral F, G, J, H, you have to go around like that. That's how you know if somebody were to say this and they didn't give you a picture. That's how you know how to draw it correctly, is you go around in a circle as you write it. And so they could not put these in alphabetical order because then they would be labeling the quadrilateral incorrectly. Because they would be doing F, G, H, J, and that's the wrong label. It has to go around in a circle. So they could have labeled it F, H, J, G. That makes me cringe, but they could have done that because that's still going around in a circle. But they cannot correct it and put it in alphabetical order because that doesn't make it go in a circle. That's technically wrong. So they really just should have labeled it differently to make it more comfortable for those of us who like things alphabetical. Shameful of them, whoever wrote this worksheet. Shameful. Okay, let's go ahead and do these translations. Would you guys rather do the translation visually by kind of using the graph to do it, or would you guys rather just do the coordinates down here? Do the graph? Okay, so what are these telling us to do? Okay, so in Avery, that book has got to go away. All right, so we're going to take the x coordinates and move them to the right 3, and then down 4. So H, we're going to go to the right 1, 2, 3, down 1, 2, 3, 4. And our new H coordinate is left 2, down 3, -2, -3. So we could have done it by doing these rules just to the numbers themselves, but instead we did it visually. So there's 2 different ways of thinking about it depending on how your brain works. You can do it either way. All right, we're taking F. We're going to go to the right 3 and down 4. 1, 2, 3, 1, 2, 3, 4. I should have labeled this, by the way, H prime. F prime. So this is left 1, down 1. G, 1, 2, 3, 1, 2, 3, 4. G prime. That's right 2, down 1. And then J, right 1, 2, 3, down 1, 2, 3, 4. J prime. 1, 2, 3, right 3, down 3. Did the quadrilateral change in shape or size? No, what do we call it when it does not change in shape or size? Rigid. Rigid transformation. No, it just has a nice little review at the beginning. All right, adding and subtracting from x and y made the shape move to the right. And what else did you say, Jack? Down. Okay. All right, before we fill in the next blanks, we're going to make a list of the rigid transformations that we have learned. Because so far, all the transformations that we've had have kept the shape the same and have kept the size the same. So the same. No shame here. The same. So everything we've learned so far has been a rigid transformation. So translations are rigid. Same shape, same size. Ooh, is the glare better? Because I actually didn't turn that lamp on today. I forgot. So maybe I should just not turn that lamp on. Or just move that lamp. Translations, rotations, and reflections. Those are all rigid. You're basically just picking up the shape and moving it somewhere else, but it stays exactly the same. So today is dilations. I do not, all the rest of them, I feel like the word kind of makes sense. Like the word in the English language is like what we would have called it. We're like, yeah, that word for that makes sense. I do not know what the word dilation means. Does anyone like English is your thing? Ooh. That word does make sense. I take it back. Dilation makes sense for what we're about to do today. Dilations are enlargements and reductions to the shape. That's what we're learning today. The word dilation totally makes sense. I just didn't think about it. Thank you, Jack, second-hand man today. A dilation is multiplication. So we're going to have shapes that are going to get like twice as big or half as big. So we're going to have shapes that are being enlarged in size or reduced in size. If I teach this class again, I'm going to pretend that I actually know what I'm talking about, and I'm going to use that exact example.
Oh my.
And I'm gonna quote you. No, it's not a plagiarism if I quote you. If I cite my sources, I'm gonna be like, Jack says. So many unicorns. Oh yes, so we have our first dead baby animals. Lots of unicorns died yesterday.
Wait, what happened?
Unicorns died yesterday. Do you guys? There was a massacre yesterday. Do you guys have dealt with absolute value before? You know what absolute value is? What's the one thing we know about absolute value? What does it always do to a number? Makes it positive. The massacre happened when a lot of students, as they were doing math problems, they weren't paying attention, and they kept having absolute value equal negatives. Just not paying attention. They were just like, I do the math, and I was like, oh, on your sheet, does that absolute value equal negative? And they were like, what? No. And I don't have an animal for that. And so it just killed a unicorn. And then as I was walking around the room, that kept happening over and over. And so we had a mass murder of baby unicorns yesterday where absolute values were equaling negative numbers left and right. So yeah, don't kill the unicorns. No, that's why you don't see any, because they were all murdered yesterday. So I know, all of them. It was terrible. Well, you see, not only is there a sticky note, but it has a lot of tally marks on it. So there was and then when I gave my calculus class has a summer assignment, and then the second day of school they have a summer assignment test. I know, I'm evil. I am evil. Summer assignment and a test. And one of the calculus kids killed a puppy on their test. A whole puppy. You guys are all like, what's up for? Yeah. They knew better. They knew better because they had me for math 3. Yes. They will.
Why does the baby puppy die?
The baby puppy dies. Let me show you the mistake. We're getting off track, but it's okay because it's math. If we have like x plus 5 divided by 5. Now, I'm going to show you something real quick. Now, you guys know 5 divided by 5 is 1, right? Okay. So this does not equal 1, right? There's something plus 5. If you said 5 divided by 5, you get rid of that, and you just say, oh, that just equals x. No, it's not x plus 1. If you do something like that, though, that kills a puppy, because you can't do that. You can't say addition, because this is addition. You can't say addition and division cancel out. You can't say that.
What's the correct answer to that, though?
The correct answer is x plus 5 divided by 5. Like, nothing reduces, you just stop. Because you don't know what x is. So, well, the thing is, the student is in calculus. They know. They've had me for math 3. You know, like, they've learned that. So it was just a brain fart. But the student canceled the thing, and I was like, oh my gosh, you killed a puppy, and you knew that was a puppy. Because they've had me. So they know. They know the baby animals. I don't think they purposefully killed a puppy. They just forgot and killed a puppy. It was very sad. All right, we got to move on. What are we talking about? Okay. When we dilate a shape, we multiply. Ooh, that's an ugly M. We multiply the coordinate points by a scale factor. So if you're going to make the shape twice as big, you're going to multiply the coordinates by 2. If you're going to make the figure 1/3 as big, you're going to multiply the points by 1/3. See how that works? Okay. So this is no longer a rigid transformation, because you're not taking the shape and moving it somewhere else. You are actually resizing the shape. And the shape doesn't really necessarily move somewhere else. It's actually going to stay on top of the old shape. It's just getting bigger or smaller. Much like when you dilate your eye, it's still in your eye. It's just like bigger or smaller in the same place. That was good. That was good, Jack. All right, next page. Okay, so shape. We've got the pre-image, we've got the image. The shape is kind of like staying on top of itself, but it's gotten bigger or it's gotten smaller. It's dilated. So this is no longer rigid. It's not the same. It's still the same shape, kind of, but it's definitely not the same size. You all see that? Okay, let's label which one is the pre-image and which one is the image. Can you guys tell which one's the pre-image? The smaller one. Okay, so we're going to say small one. I'm going to label this right here. This is the pre-image. The bigger one is the image. Okay, so did this get bigger or smaller? It got bigger. So am I going to call this an enlargement, or am I going to call this a reduction? Enlargement. So both of them are called dilations, but this is a dilation that happens to be an enlargement. It got bigger. Okay, so when I multiply this, when I do a scale factor, is this going to be a scale factor like a 2, or is this going to be a scale factor like a 1/2? It's going to be like a 2, something like that. It's going to be something that makes it bigger. Does that make sense? Okay. So they say how much larger is f prime, g prime, j prime, h prime than f, g, j, h? This is the scale factor, and explain. So the question we have to ask ourselves to figure this out is we're going to say, what did we multiply the pre-image by to get the image? And then this is the scale factor. So the question we're answering is, what did we multiply the pre-image by to get the image? This is the scale factor. Okay? Well, I think it means that we probably have some decimals in there.
No.
Oh, but probably some good decimals. Don't be scared.
No.
Okay. Well, we do. Look, we do have decimals. They got some decimals in there. Okay. So, but look at this. But look at this. F went from negative 1.5 to negative 3, and from 2 to 4.
It's not that bad.
It's not that bad. What's the scale factor? 2. Scale factor is 2. Now, that happened to be an easy one, but let's kind of write out a math formula that we could use to figure that out, okay? So the math formula that you could use if it's not easy. Yes. What do you think it is?
Well, I feel like it has something to do with division.
Yes.
Like 3.5 or the 3. You find the coordinates, and you divide that.
Yeah. So if we think about how this works, it would be pre-image times scale factor equals image, right? If we were to think about how that formula works, it's pre-image times scale factor equals image. So if we wanted to solve, if we wanted to find a scale factor, then what should we do with the pre-image? How do we undo this multiplication? Divide it over. So we're going to say scale factor equals image divided by pre-image. That's reasonable, right? Image divided by pre-image. Okay, so we're going to say the scale factor, I'm going to write it out in words just in case you forget later what this means, is image divided by pre-image. So that's like negative 3 divided by negative 1.5, which is 2, or it's 4 divided by 2, which is 2. And because it has to be consistent for all the points. You can't have the x-coordinate doing one thing and the y-coordinate doing the other. It's all of the points doing the same thing. You should be able to do it to multiple different coordinates and get the same answer. Which means if you want to avoid the decimals, if you got decimals for some x-coordinates but the y-coordinates are nice, you can just look at the nice numbers and use just the nice numbers to figure out your scale factor. You don't have to look at the decimals if you want to avoid the decimals. Does that make sense? Okay, so this is going to be a really important formula for today. If you got some colors out, I'd maybe circle that, highlight it, get that. That's something important in your notes, is to be able to figure out the scale factor of a dilation. That's going to be our important formula for today. All right, we're gonna cross out part C. We just did the work. Cross out part C. We just did the work. But we're gonna go ahead and write down the rule. We got x comma y goes to, and our rule is 2x comma 2y. There's our rule. 2x comma 2y. There's our rule with our scale factor. 2x comma 2y. Okay. So for the next one, they said the rule for dilating a quadrilateral, they said xy goes to 6x comma 6y. What is this rule? What did they do? They multiplied by 3? They multiplied by 6. So what did they do? They enlarged the quadrilateral by how much? Okay, they enlarged the quadrilateral by a scale factor of 6. Okay. All right, dilate by a scale factor of 3. How should we write that rule? 3x, 3y. Okay. Is this an enlargement or a reduction? I fell asleep. It's an enlargement. Why? Because why?
It's a whole number.
It's a whole number. Well, what if I gave you, no, it doesn't work. What if I gave you the fraction 5 over 2? Is that a reduction because it's a fraction?
Well, it's greater than 1.
Oh, it's greater than 1. Okay. So we're going to say it's an enlargement because the scale factor is greater than 1. 3 is greater than 1, therefore it's an enlargement. So we're not going to say, oh, fractions are reductions and whole numbers are enlargements. That's not necessarily true. Fractions can be enlargements as well. We're going to say either the number is smaller than 1, larger than 1, okay? All right, go ahead and flip the page. All right, scale factor of 1/2. Okay, how do we write the rule? 1/2 x, 1/2 y. Okay, reduction, and less than 1. And I'm going to write it like this. I'm going to say, and you'll understand why I'm doing this in a second. So we're going to say that 1/2, and basically this is how I write, oh, 1/2 is a fraction, but it's a fraction that's smaller than 1, as opposed to being a fraction that's bigger than 1. Because we know we can have fractions bigger than 1. That's what I just made the point of with the 5/2. Okay. So I'm saying this is a fraction that's smaller than 1. Okay. If you are uncomfortable with this notation, you can write the words out. It's a fraction that's smaller than 1. You can write those words if that's more comfortable to you. Okay. For this one, enlargement or reduction, point 4. Reduction, okay. And what is the reason why? Yeah. Point 4 is technically 4/10, right? If we were to write that as a fraction, technically 4/10, or technically 2/5 if I was to reduce that fraction. So point 4 is actually a decimal that is smaller than 1. It's a decimal that is smaller than 1. All right, we're about to get weird here. What's weird about this one? Okay, it's a 5, but it's a negative number. Okay, so it's still an enlargement. It's still going to get bigger because the 5. Can you guys picture what the negative's going to do? It's going to flip it, yeah. So if your picture was up here, it's going to reflect it in all different ways. Can you guys remember, what is the isn't there a transformation that changes the sign of the x and the y? Do you guys remember what it is? Wait, or is it a rotation? Is it a 180-degree rotation?
Yeah.
Does anyone have their flip book handy? Can somebody check?
Yeah, it's a rotation of 180. Yeah, it's 180.
It's a 180-degree rotation. Interesting. So this one's going to enlarge it for sure, right? Because you're taking your coordinates and you're multiplying it by 5. So it being a negative doesn't make it smaller, right? It being a negative does something else. So the 5 is still going to make an enlargement. The negative apparently is going to do that 180-degree rotation. Kind of interesting, right? So still an enlargement. Okay, so we're going to say enlargement. And that's because, and here I'm going to do absolute value of -5 is greater than 1. Are we comfortable with how I wrote that? Because the size of the number. So it's a negative number, but the size of the number is still bigger than 1. 5 is still bigger than 1. Does that make sense? So I don't care that it's negative. The negative is doing something else. But the 5 is still taking each coordinate and making the coordinate numbers large, which is what's making the shape big. Does that make sense? Okay. And then if you want to write a note to yourself, remember -x, -y is capital R 180, that 180-degree rotation. Kind of interesting. So that's doing something else. It's just not messing with the size. Okay. All right, so here they want us to draw a shape. Let's go ahead and draw the shape. We've got A is negative 1.51, negative 1.51. There is A. B is negative 1, 0. And C is 0, 1. Now, I'm going to put a little note to the side. All the dilations we do have a center of 0, 0. We just automatically assume that. I'm going to be honest with you, I don't even know how to do a dilation if the center is something other than 0, 0. I don't even know how. I'm sure that I'm mathematically capable of doing another center, but I would have to Google it and be like, Google, tell me how to do a dilation with another center, because I don't know it off the top of my head, okay? I'm telling you that because it is possible, and in the instructions of something, that they would say, dilate this with a center of 0, 0, and you'd be like, the instructions have never said that. They've never said it, but you've been doing it the whole time, okay? So just a heads up, all the dilations we do technically have a center of 0, 0. So if you ever see that, don't stress. You actually do know how to do that. Okay, so here's our little triangle. They want us to dilate it by a factor of 3. So what is the rule? 3x, 3y. Yes. Yes.
It says dilation with the center not at origin, dilation on the corner axis where the center is not origin can be accomplished by observing the vertical and horizontal distances of each vertex from the center of the dilation.
Sorry, I thought you said you pushed the notes up and it said that, and then I stopped listening because I was looking for where my notes said that. You said you looked it up, so now I need you to read it again. Yes, okay, read it again because I stopped listening.
The dilation on the corner axis where the center is not the origin can be accomplished by observing the vertical and horizontal distances of each vertex from the center of dilation. So, like, it's the same thing as x equals 3 with the transfer.
Yeah, you would just count your distances and then double or triple your distances or whatever.
Formula, but that's,
yeah, that sounds miserable.
That's off math bits.
Yeah, MathBits is good. MathBits has it's a website you can get. There's worksheets on there and stuff. I've stolen their worksheets before. Shh, don't tell. All right, let's do the points for this, but I'm going to show you a cheater method for another way you can do it because that's what our next worksheet has. All right, A prime. So we're going to take these numbers and we're going to multiply them by 3. Negative 1.5 multiplied by 3, so we're doing negative 1.5 plus negative 1.5 plus negative 1.5. Negative 4.5. Positive 1 times 3. Okay. Negative 1 times 3. 0 times 3. 0 times 3. 1 times 3. Okay. I'm going to switch colors so that I don't confuse myself. Okay, so we're graphing negative 4.5, comma 3. 1, 2, 3, 4.5. 1, 2, 3. Here's my A prime. 1, 2, 3, negative 3, 0. 1, 2, 3, 0, 3. B prime, C prime. Okay. Brains are good?
Oh, don't forget C. Oh, yeah.
Ryan, you always coming back. Jack. Ryan, Jack. I don't know where the Ryan came from. But did you see how quickly I corrected, though? That was quick.
Do you have Ryan?
I don't know. But that was in my head, so maybe I did. Oh, I don't. Oh, yes. Yes, I did. That's the connection. Your last is familiar. That's yeah. Navigation though, because that's not how I said it in my head. I'm not going to tell you how I said it in my head,
I
but
don't know. Mr. Ron says profile.
No.
Please, I want to know.
I am not telling you. All right, next problem. All right. What is this one?
Oh, that's a logic.
Enlargement. What is this one? Reduction.
Rotation of 180.
This one's an enlargement with a rotation of 180. Tricky. Oh, sorry, we move so fast. Woo. 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 Okay, the next one, don't say them out loud. Don't say it out loud. Just go ahead and take each vertex and dilate them by a scale factor of -3. So we have xy goes to -3x, -3y, and we're rewriting each of our coordinates.
This thing,
Uh-huh.
it says K. K stands for the figure.
Yeah, they're probably using K as like the scale factor. Like KX, KY. Yes. Oh, thank you. All right, and then when you're done with that, go ahead and do your matching. I think the hardest one on the matching is these two. I had to actually go back and get I'm going to be honest with you, confession time, I have not kept up with my flip book. So I had to go back and flip through all my notes and figure out what those two were. The rest of them I thought were pretty easy, but yeah, those two I had to look up. No, you're going to do them. But these two are the hard ones, is what I'm saying. You might need to get your flip book out to figure out which is which. All right, so go ahead and finish that up. I'm going to hand out the next page. All right, now with this one it says, first, draw a dilation on triangle ABC with a center of A and a scale factor of 2. And you go, okay, that's weird because it says A is the center and we've never had the center specified before, which is kind of why I told you guys before, center 0, 0. And then it says center of B and a scale factor of, I did a scale factor of 2 for every single, you're going to ignore my answer key in the back because it's wrong. I'll fix it in a little bit. I'm gonna have to do this one over again. Scale factor of B, or center B scale factor of 3, center C scale factor of 1/2. So they're asking you to change the center of the triangle every single time you do this problem. And then if you notice, there's a grid here, but what is missing off of this grid? Numbers, and there's no X or Y axis. Are you guys seeing that? Okay. So the cheater way that I did this problem is when it said use center A, I was like, cool. When I do that problem, A is 0, 0. Ah. And then when they want me to do center B for that problem, B is 0, 0. Do you see what I'm feeling? Okay. Now, for this, don't look at my answer key. Can you take my answer key down, Bentley, actually? Because I did a scale factor of 2 for every single, yes, it's totally wrong. Well, A is right, but then B and C are wrong because I did 2 for every single one. So with this, we're going to manipulate the center to make it easy for us to do each of these problems, okay? Now, if you try to use this grid for all 3, it's going to be hard for you to keep track of it. So my recommendation would be to use this picture for maybe the first one and then get graph paper for the other 2, or use 3 different colors. So it's up to you however you want to do it. But if you think it might get confusing for you, I would switch to graph paper because I was confusing myself doing the whole thing in pencil because it's a lot of drawing on top of itself. Okay? So for this one, if I make the center at A, then I'm just going to go ahead and write down the coordinates. And I'm going to write down the coordinates every time because for each drawing, as my center changes, my points are going to change every time based on that center. Does that make sense? So for the first one, A is 0, 0, but for the second one, B is going to be 0, 0 because B is the new center. So they're going to change for every single problem. So if A is 0, 0, that means that for this one, it's 1, 2, 3, 4. 1, 2, 3, 4. So B is 4, 4. And C is 1, 2, 3, 4, 5, 6, 0. Okay. So center of A and a scale factor of 2. But isn't it fun that we do like color coding everything? It gives you a chance to use your colored pens. You're like, Mom, I have to have colored pens for Miss Rice's class. We actually need them. Use them every day. Like, we need them. I can't understand math without it. It's important, you know? Okay, so we're multiplying everything by 2. So 0, 0 is going to stay 0, 0. What does 4, 4 become? 8, 8. And then 12, 0. Okay. So 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is B prime. And then 8, 9, 10, 11, 12. There's C prime. Okay. Let it be known that Jack said holy moly and it wasn't ironic. Triangle? Okay, so we drew the triangle. The next set of instructions say, by what factor do the base and the height of the triangle change? So we need to find the base of the original triangle and then the base of the new triangle. The height of the original triangle, the height of the new triangle, okay? So 1, 2, 3, 4, 5, 6. So the base of the original triangle was 6. The base of the new triangle is 12. The height, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So the height was 4, the height went to 8. So what scale factor did the base and the height change by? 2. Okay, the base and the height changed by a scale factor of 2. Are we okay with me shorthanding this? SF for scale factor?
Oh, wait, do you want me to like write that down? I'm just gonna write.
You can draw the shape, but this is one of the questions that's on the back that you have to answer. So it's not just for funsies. Okay, the next question is, by what factor does the area of the triangle change? Okay, so what's the formula for area? Anyone remember? It's base times height, but one more thing. Divided by 2. So we're going to do 6 times 4 divided by 2 is the first area. The second area is 12 times 8 divided by 2. Okay, so 6 times 4 is 24. 24 divided by 2 is 12. So the first area is 12. 8 times 12. 10 times 8 is 80. 2 times 8 is 16. 80 plus 16 is 96. 96 divided by 2. 45 plus 3, 48. That was too much in my head. Okay, so what's the scale factor of the area? 4. So things that were measured with a length doubled. Things that were measured with an area quadrupled. Lengths doubled, areas quadrupled. So that's interesting. Okay. And then it says, what do you notice about the angles compared to the original? So angle A stayed the same, because angle A and angle A are, it's the same for each triangle. What do you guys notice about the angle B's? They're the same. What do we notice about angle C's? They're the same. So, okay, we're going to say the angles stayed the same. Angles stayed the same. Okay, so we have completed all the requirements for center A, scale factor 2, so we are done with that. Then we move on to the next one. So this is what is required for each problem. Does that make sense? Okay, so I'm going to help you write the points for the center of B, but I'm going to let you finish the problem yourself. So center B, I'm going to label this. This is center A. There's not an answer key in the back because when I did it last night, I did all of them with the scale factor 2. Yep, I was watching TV. Okay, so the center of B, now we're going to say this is 0, 0. Okay? Does that make sense? We're taking the B, we're saying B is 0, 0 this time. We're saying you can do it on the same one. Just know that if you use pencil for everything, you're going to be squinting more and more for each problem because it's going to get harder and harder to keep things straight. Okay, just a heads up. So if you are using the same grid for each problem, I would switch colors. Okay? All right, so center B means that B is 0, 0. And if you're doing that, if you're not switching to a different piece of grid paper, then instead of doing A prime, B prime, C prime for the second picture, I would switch colors and I would do double primes. Okay, so just to make things not hard on yourself, I would definitely change by labeling. Okay, so that means that A is 1, 2, 3, 4, 1, 2, 3, 4. So it's left 4, down 4 for A. Understand how I got that? So if B is 0, 0, then A is left 4, down 4. Does that make sense? Okay. And if B is 0, 0, then C is 1, 2, 1, 2, 3, 4. Then C is right 2, down 4. You see that? C is right 2, down 4. Okay. Okay. And now you're doing scale factor of 3. And I'm going to leave it there, and I'm going to work on this answer key so I can put it up for you guys to check your work. Sound good?